Calculating total amount of power consumed by a parallel circuit is very similar to calculating the amount of power that's consumed in a series circuit. And the result says the finding of the power dissipation in each one of the loads, and they are added together to get the total amount. Let's calculate this first one. We have three different formulas. We've got voltage times current for the first power equation. The second is V squared over R. And the last one is the current squared times the resistance. Let's take a look and see which one we could use for this parallel connected load. In the illustration, there's two branch currents. This is I1 going through this load. I2 is the second branch current, remembering that the sum of those two equals the total amount of the current. And we can also use that IT, the total amount of current, to find the total amount of power dissipation by the circuit, or use it as a check. But let's take a look at the individual power calculation and see what we have. In this first one, we've got 10 ohms. To calculate how much power, we could take voltage squared divided by the resistance, it's this one right here, and find out what this power dissipation is. So in the very first one, we have 10 volts squared is 100, and divided by the 10 ohms gives us 10 watts. So we're going to put that right here for P1 for this very first branch, 10 watts. Let's take a look at the next one. That's going to be 100. It's 10 squared, and divide that by the 20 ohm, that's right here, 20 ohm resistance, and it gives us 5 watts. The total amount of power dissipation is 15 watts. If we wanted to use one other type of calculation to check our answers here, what we could do is take the two branch currents and add those together and take that to multiply it times the voltage and see what that power dissipation is. So in this particular case, 10 volts divided by 10 ohms, 10 divided by 10, equal to 1 ampere. I'm going to put that 1 ampere here. On the second branch current, I'm going to take 10 volts and divide that by 20 ohms. This is going to be 0.5 amperes. If we sum those two together using Kirchhoff's current law, we have 1 plus 0.5 gives us 1.5. 1.5 amperes is I sub t, or the total amount of current. If we take that and multiply that times 10 volts, we come up with 15 watts. So taking these two branch currents would be 1 plus 0.5 gives us 1.5 amperes. Taking this, multiplying that times 10 volts, we wind up with 15 watts. This is what we calculated when you use the I squared R method here, and this is the V times I method, which is right here.